Okay, boys and girls, really quick for my morning class, for my afternoon class, who did not get to set up your table of contents, go ahead and set up your table of contents. Today's date, multiplication, and on page 26. Once you have done that, my afternoon class, go ahead and copy down these notes. My morning class should already have these notes, and we're going to go ahead and get started. This is our first part of the lesson, these notes right here, and then we're going to get into our second part in order for you to be ready for class tomorrow. I don't want to get too much, any further behind than what we already are right now. So I want you to be a little bit more prepared. I can't talk today. I'm sorry. A little bit more prepared for class tomorrow. Okay, so we started talking about multiplication. So some of the ways that we said that we can represent multiplication were equal groups, arrays, area models, number lines, and just different ways that we can represent. And there were so many great answers that I heard in class today. And parents, as we're moving throughout the unit for unit, of multiplication and division, I will be uploading more resources, PowerPoints, as we're adding to our ways to represent multiplication, so that you all will can better help your child at home and feel more included with the lessons in the classroom. So, students, today we talked about arrays specifically because we wanted to use an array. We wanted to use an array for our representation today. So in this case, we created 10 times 5, which equals 50. So I see 10 equal rows, and our rows are going side to side. So if I'm going side to side, 10 equal rows. Okay, they're all the way down, and if you were to count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there are 5 in each of the rows. So when I see this array, I have 10 rows and there are 5 columns, but there are 10 equal rows, 5 in each row, and there are 50 total number of circles. So now that we have that, just breaking down the number sentence for multiplication, 10 times 5 equals 50. Our two factors are 10 and 5 because these are the numbers that we are multiplying together. And then our product is 50, which is the answer to a multiplication sentence. So go ahead and write down these notes. Okay, so now that we have our factors out of the way in our product, now we're going to move forward. Now, so we have our array set one way. Now, if I was to take this whole array and turn it to the side, okay, and we're actually going to draw a picture of what it looks like to the side. So we're going to turn it to the side. I now see that I have 1, 2, 3, 4, 5 rows, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots in each row. So that's what we're going to do. We're going to draw our array of how it looks to the side of 5 rows with 10 dots in each row. So let's do it. So we have 1, 2, 3, 4, 5, and there's going to be 10 dots in each row. So we're going to draw it 10 times. And it's always good to go back and double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know why I'm counting out loud. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8. So this is 9 dots in each row. And then now we have 10 dots in each row. So now I see that there are my markers is not writing. Now I see that there are 5 rows and there are 10 columns, which there are 10 in each. So I see 5 equal rows. There are 10 in each row. And just take a moment to count to see how many are there total. And I'm just filling in my notes. Okay, so if you count them total, you should end up having 50 total, because only thing we did was just take our array and we just turned it around. Okay, so if I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and I do the same here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, I should still have 50 in each row. I mean 50 total, I'm sorry. Okay? So basically, we have 10 times 5 equals 50, and then we have 5 times 10 equals 50. And so on the back of your paper, or on the next page, okay, we can go ahead and say that this is a part of the commutative property of multiplication, because what we just did was model 10 times 5 equals 50, and then we turned it around to say 5 times 10 equals 50. And basically with the commutative property of multiplication, it says that it doesn't matter the order of the numbers. So two numbers can be multiplied in any order and the product will stay the same. Okay, so the same goes for 2 times 3 equals a number, and 3 times 2 equals a number. But the main thing I want you to do when you fill out these as your example, I want you to draw an array. So I want you to draw an array with 2 rows, 1, 2, and there should be 3 in each row. And then I want you to draw an array with 3 rows, 1, 2, 3, and then there should be 2 in each row. So, and then you can see the difference in how the array looks. So even though the arrays look different and they're turned to the side, or they look kind of almost the opposite of each other, that the total still stays the same. And that's what we're going to get into with our commutative property of multiplication tomorrow. So just fill out your arrays for both of these. Fill out your product. And I want you to also circle your factors. In the problem above. And I want you to put a square around the products above. Okay, so for example, if I wanted to circle my factors here and put a square around my product, I can do that here, and I can do my factors here and my product here. I want you to do the same in these two problems right here. All right, see you tomorrow.